This program is about a bear, Ursa Major, the Great Bear, one of the most famous constellations in the entire sky, and one I'm sure you'll recognize. The 7 main stars make up the pattern we call the Plough, and Americans call the Dipper, and they're fairly bright, of this second magnitude. Now, a magnitude, as I'm sure you know, is a measure of a star's apparent brilliancy, and the lower the magnitude, the brighter the star. So, very bright stars are magnitude 1, and with the naked eye, we can see down to magnitude 6. Now, you'll always find the bear somewhere, because for Britain, it never sets. The actual pole of the sky is in Ursa Minor, marked by the pole star, and Ursa Major goes round and round and round. Even at its very lowest, as it is now, it's still well above the horizon. It's what we call circumpolar. So in this program, we're going to tell you all about the bear, what we find there, and the interesting points about it. So now, out to my garden, where we find Chris Lintott with my 12.5-inch telescope.
I think even if they don't know anything else about the night sky, everybody knows the 7 stars that make up the Plough. At a first glance, all of the stars look the same, but in fact, they've got their own personalities, and a few simple observations can help us really get to know these stars. To start with, we'll need to know the distance to each of the stars. We'll want to know the brightness, how bright they appear in the sky. Then, crucially, we want to know the star's colours, because the colour tells you the temperature of the star. Blue stars are hotter than yellow stars are hotter than red stars. And so if you look at a star like Dubhe, say, the top right star in the pan of the saucepan, if you think of the Plough as a saucepan, if you look at Dubhe, you see it's a golden, orangey red colour. I mean, when you first look, it will look white, but if you look carefully, you can really bring out the colour. And it's particularly easy with Dubhe because it's got a companion. It's got a nearby star about 1/10 of a degree away that appears blue, and the two make a really nice contrast. They're not a real double, they're just passing through space together, but they make a beautiful sight. We go down to the bottom right of the pan, we see Merak, and this is the other one of the 2 pointers. And they're called that because if you take Merak and you draw a line through Dubhe in the sky and keep going, you'll hit Polaris, the pole star, the point on which the whole sky turns. You can also use Merak to find one of my favourite objects, the Owl Nebula. And actually, Ursa Major has its beautiful stars, but it's peppered with galaxies, nebulae, double stars, and all sorts of interesting things that we'll come to a bit later. If we continue our way round, Fad's the next one, bottom left. It's the boring star of the group. There's nothing much to say about it. The 4th and final star in the bowl of the Plough is Megrez in the top left, and this is the faintest of all the Plough stars. The next star along, the first of the handle, Alioth, with its wonderful name that sounds like it comes from Lord of the Rings, really is a variable star. It gets brighter and fainter over time. In its case, it only does so very slightly, but other stars in the sky vary wildly. Alioth's the brightest of all the Plough stars, but the next one along, in the middle of the handle, is probably the most famous. It's Mizar, and it's not famous because of anything it's done, but because of the presence of a companion that you can see with the naked eye, the fainter star Alcor. And the 2 of them used to be known as the Horse and the Rider. Moving on to the end of the handle, we come to Alkaid, the final one of the Plough stars, and this is much more distant than most of the others, with only Dubhe further away from Earth. So those are the 7 stars of the Plough, but the Plough isn't the whole constellation. It's part of the greater constellation of Ursa Major, the Great Bear. And if you imagine the bear in the sky, the handle of the Plough is the tail, the body of the bear is the pan of the saucepan, there's a fainter snout, and then other stars mark out long, spindly legs that stretch down towards the horizon.
Well, the Great Bear is certainly a very prominent constellation, but it does have many names and many stories attached to it. Isn't that correct, Paul?
It is. The constellation we know as the Great Bear starts off with Greek mythology, doesn't it?
It does. It's right, Callisto and Arcas.
It does. It is a wonderful story. So the idea is that Zeus, king of the gods, was rather infatuated, shall we say, with the nymph Callisto. But unfortunately, Zeus had a very sort of demanding wife who got quite jealous quite quickly, and she turned the poor Callisto into a bear.
Most unfriendly.
Most unfriendly.
Years later, her son Arcas was out hunting with bow and arrow, and he saw the bear.
He did, but thankfully Zeus was on hand to avert disaster and hurled them both into the sky, giving us the constellation of Ursa Major.
And that's why both bears have such long tails. But there were stories elsewhere also.
There are. In fact, coming close to home back here in England, the people of medieval Britain saw the constellation rather like an old-fashioned plough, sort pulled by oxen on farms of long ago. The French, they had an interesting name for it. They called it La Casserole.
They would. And elsewhere in the world there are many stories.
There are indeed. The Arabs actually saw it as a funeral procession. They saw the bowl of the casserole dish as a coffin, followed by 3 mourners, which I think is quite pretty. But I think as you go further east, the stories get more and more elaborate.
Burma?
In Burma, there's a lovely story in Burma. They see it as a shrimp. So they don't use all the constellation. They just use the stars that form the head and the forearms of the bear. So only a bit of the constellation is used.
What about China?
To them, they see the stars of the plough as carrying a celestial bureaucrat around the heavens, in particular around the North Pole of the sky, attended to by 2 very loyal servants. Brilliant stuff.
I don't think you can better that one.
No, I don't think so.
But one thing you've got to remember, all our maps are 2-dimensional, but space is 3-dimensional. And the Great Bear is not quite what it seems. And Chris, outside on the garden, will explain just what I mean.
I've got my own version of the plough, and it's just like the one you see in the sky. Whenever you see an arrangement of stars like this, it's tempting to believe that the pattern means something, but it doesn't, and I can show you why if we head into space. Each of the stars is at a different distance from the Earth, so as we move through space, the pattern changes, and what was the oh-so-familiar plough is now just a random collection of stars. And that would be true of any constellation. The plough, though, has something special going for it, and that's the fact that the 5 central stars really are associated with each other. They were born together and they travel through space together. In fact, there are more than 50 stars scattered right across the sky, way beyond the borders of Ursa Major, that belong to this same stream of stars travelling through the Milky Way together. Of course, all stars move, and so if we run the clock forward by 100,000 years, you'll see the familiar shape of the plough disappear entirely. And with the constellation gone, let's focus on one of its most interesting stars, Mizar.
You managed, Pete.
Yeah, I'm fine.
Oh, winter's arrived.
It certainly has. It's very, very chilly tonight.
It's cold.
Right, can you take that one?
Yep,
and
I've got
that
these
one?
2.
Okay. Let's just pull that out of there.
Okay, you got it?
There we go. I'm just going to pull that round here.
It's a lovely clear night, Pete.
It is, isn't it?
Very nice. There you go, look. Mizar and Alcor. And Mizar really is a fascinating star, Pete, because of all the wonderful stories attached to it.
Absolutely. It's a really easy star to find, isn't it? It's the second star in from the end of the handle of the saucepan, if you like.
That's right. And if you look at it closely, there's something very interesting about it, isn't there?
There is, because there's a faint companion star next to Mizar, and that star is actually named. It's called Alcor. It used to be believed they formed what was known as an optical double star.
Right, and we can demonstrate that quite easily, can't we? Because we've got our torches here. You're going to be one star.
I'm going to stay where I am.
I'm going to be another star. And I'm going to go out there into the galaxy.
OK. So basically, Paul is now heading back out into the galaxy so far away from me that I can't have any gravitational influence on him at all. So we're just 2 stars that happen to appear in the same line of sight from the Earth.
You know, Pete, they used to say that Mizar and Alcor was a test to see how good your eyesight was.
I've never really understood that because I have no difficulty seeing Mizar and Alcor at all.
No, not at all. It's a very easy pair to separate. We have, of course, a nice demonstration here to show what it looks like in the night sky. And isn't this pretty?
It is. I mean, what we've done, we've put together a number of torches to represent the various stars. The view we've got of it at the moment is the sort of view we'd have if we went outside at night and looked just with our eyes. You can see the bright star, which is Mizar, and the fainter one next to it, which is Alcor. Now, if we apply a bit of magnification, so we're now using, say, a small telescope to look at the system.
The system changes a bit, doesn't it?
It does, because as we start to zoom in, you can see that the brighter star, that's Mizar, actually has a fainter companion next to it. So Mizar is actually a double star. Now, in this case, it's not like the optical
No,
double.
this is a genuine binary, isn't it?
It is.
And these two are connected and gravitationally bound,
They
unlike
are.
our optical double. And we can demonstrate that again with the torch here.
Okay.
That's right. You got your torch on.
I'm going to be the...
You be the primary star.
primary star. I'm going to stay where I am.
Yes, you stay where you are, and I'll be the secondary star. So in a genuine binary star system, I would be orbiting you round like this.
That's right. You just go round and round,
Round and round, because we are gravitationally connected, unlike the optical double, which are not connected at all.
No, that's exactly right. But the story doesn't stop there, because it was in 1889 when Pickering was looking at the spectra of the two stars Mizar A and Mizar B. I mean, the spectra is where you take the colours of the star and you spread them out, basically. Yeah. He was looking at the spectra and he noticed that there were actually additional spectra moving in amongst there.
The fingerprints of two other stars.
That's right. So it turns out that each of the stars in the Mizar true binary is double again.
So it's a quadruple system, and that's known as a spectroscopic binary, and we can demonstrate that very quickly. There's two stars so close together that their light appears as one.
Yes, that's right.
And that's not all, is it, Peter? There's still yet more to the story.
It gets even more interesting, Paul, because in 2009 it was discovered that Alcor is a spectroscopic binary in its own right.
So Alcor is itself a binary star.
That's right. But it got even more interesting than that, because it was then realised that the Alcor system and the Mizar system were gravitationally bound. So they weren't an optical double, as originally thought.
They're actually all gravitationally connected. That's 6 stars, a 6-tuplet system.
It is, and it's only one of 2 sextuplet systems known in the entire sky, and the other one being Castor in Gemini.
Of course, yes. And actually, if you look at the star Mizar and Alcor in a telescope, you see there's a third star just off to the left, isn't there?
An interloper.
An interloper. Do you remember what it's called?
It's Sidus Ludoviciana.
Oh, it's very good. Yes. Also known as Ludwig's star.
But there's a really interesting story attached to that, isn't there?
There is, because he thought the observer that discovered it thought it might be a planet, didn't he?
Purely for financial gain, he thought it would be a clever idea to name it after his sovereign.
Yes, and do you remember the sovereign's name?
Oh, that's the Landgrave Ludwig of Hessen-Darmstadt.
Very good with German names, Peter. Yes, but it wasn't widely accepted that third star
he
was
was
a planet.
ridiculed by the other astronomers at the time, who realised it was just a star.
That's right.
And but it's quite interesting that it actually retains its name to this day. And that was the star that could have been a planet for a month.
Yes, but not for very long. So leaving behind Mizar and Alcor, we do have some genuine deep sky stuff in Ursa Major. For example, M97, the Owl Nebula. And this is a planetary nebula. It's not associated with the planets at all, we should say.
No, that's right. The thing about a planetary nebula is that it does look like a ghostly planet, typically.
And that's what the people thought they were, didn't they?
That's exactly right. But in reality, what this is, it's a star, similar mass to the Sun, which has got to the end of its life. When that happens, it starts to swell into a red giant. Yep. It starts to pulsate, and the outer layers of the star actually get blown off from the core. And what you're left with is a very hot, burning core, which sends out quite intense radiation through these layers which are moving away from it, and it causes them to glow.
And they really can be quite pretty, can't they?
They can. In some instances they are absolutely beautiful, but I think in the case of the Owl, to me it always looks a little bit bland. I mean, it's basically a faint disc with 2 dark patches in it.
That's right. Of course, it was the Earl of Ross that thought those 2 dark patches within the nebula made the thing look like the face of an owl, and that's where the name came from.
Absolutely right.
And we can demonstrate why it looks the way it does, can't we?
We can. Now,
look what you found. It's the night for demonstrations.
This is an apple from Patrick's garden, and we've cut a hole in the centre of it.
Yep.
Now, to make this work, you've got to imagine that this is a sphere of gas surrounding the central star, which is blown off its outer layers.
Okay.
And that sphere of gas would be incredibly tenuous, so you'd actually be able to see through it.
Okay.
Which isn't the case here, of course, with the apple. But if you can imagine that. Now, because there is a hole through the centre of it, if that was facing the Earth, you'd see a ring of material with a hole in the centre.
Yeah.
But in the case of M97, the actual sphere is tilted to the side. So what you can see is the entrance to the hole, and you can see the exit to the hole, because you can see through the gas cloud. Right. And that gives the impression of 2 dark patches within the ring of the nebula.
So really, then, those 2 dark patches are the entrance and exit of a hole, and we can see that because the whole thing's rather translucent.
That's exactly right.
Well, Pete, M97 is, of course, situated within our own galaxy, but there are objects in Ursa Major located far beyond the realm of the Milky Way.
To begin our exploration of beyond the Milky Way, I thought we'd start with two of my favourite galaxies, M81 and M82. To find them, go back to the bowl of the Plough and go to Fad, the bottom left star. Draw a line from there up to Dubhe in the top right, then keep going for about the same distance again. And if you do that and you use binoculars like these, you'll be able to see two faint fuzzy patches. Now they won't look like much, but each of these is a galaxy, just like our own Milky Way, home to billions of stars. With binoculars though, you won't get much further than seeing them as faint fuzzy patches, and to see more, we need a telescope.
Well, Pete, here we are with Patrick's 15-inch reflector, and this really will do justice to M81 and M82, won't it?
It will indeed, but the thing to remember is that you don't need a huge telescope to actually see these two beautiful objects.
No, you don't.
In fact, one of the first views I ever got was with a really small telescope, and I can remember looking at M81, M82 with a low power eyepiece, which gave me a very wide field of view, and to see these beautiful objects just hanging there in space.
They really are quite remarkable objects. I had a similar view with my small telescope when I first started out, and it really was quite incredible to see, because they're at slightly different angles, and M81 looks quite different to M82, doesn't it?
Does.
Even in a small telescope.
That's really what hammers home about this pair of galaxies, because M81 looks very, very elliptical.
Yes.
I mean, it's a spiral galaxy, but it's tilted over to us so that it looks a bit like a fuzzy ellipse of fuzzy elliptical patch in space. Whereas M82, of course, looks very linear. It looks like a little
It does, a very thin smudge of light, isn't it?
I mean, its name is the Cigar Galaxy.
Is it? I've always found that, as it's the fainter of the two, but I've always found it slightly easier to see than M81. But of course, as you move up, so something like a sort of medium to large size telescope, then the structure really does begin to come out, doesn't it? M81, for example, through this is really quite a sight.
It's astonishing, because you then start to pick out the spiral arms of M81, and you can see sort of knots and blotches in those spiral arms, which are star-forming regions in the galaxy itself.
Yes, and of course the two galaxies are 12 million light years away. It may sound quite a distance, but in galactic terms it's not really, is it?
It's not that far away at all, is it really? But coming back to M82, if you look at that through a large telescope, you see a sort of broken structure in the centre.
Right.
It's a very odd galaxy. It's actually quite a peculiar galaxy anyway.
It is.
But it does look like it's completely distorted in the centre. You see this sort of mottled appearance, which are the dust lanes running through.
Yeah, I think that's far more striking than the spiral arms of M81, personally.
Yeah.
And M81, of course, is actually quite a large object in the sky, isn't it?
It is. I mean, the apparent size of it is astonishingly almost the same size as a full moon. Obviously a lot dimmer, but it's the actual dimensions lengthwise is about the same as a full moon, which is incredible.
It is. It's remarkable.
I always enjoy looking at those two galaxies. They make up a lovely pair. But of course, my 15-inch reflector is a very modest telescope. And with larger telescopes, you see more and you learn more. That's true, isn't it, Chris?
Absolutely. For example, let's say we want to understand where stars form in these galaxies. Let's take M81 first. Well, if you want to know where stars are forming in a galaxy, you look for the blue stars, because blue stars are massive and only hang around for maybe a few tens of millions of years. So where you see blue stars in a galaxy, you know that star formation has happened in the last 10 million years or so. You can see that with M81, just like they would be in the Milky Way, star formation takes place in the spiral arms. So you have these beautiful blue spiral arms. If you look at M82, it's a bit of a mess, really. It's not just a normal cigar shape you see in the small telescopes. You have bright blue young stars scattered throughout the whole galaxy. There's dust everywhere, these dark lanes, and it's a really very complicated picture indeed. So to try and understand it, what we do is, instead of sticking with optical light, the light that your eyes and mine can use, we have to use the whole range of light available to us. So that means everything from radio waves with really long wavelengths, which show us all sorts of energetic processes that are going on, through to infrared, just slightly towards the red end past visible, where we see the cold dust and the places where stars are forming, through to the X-rays and gamma rays, which tell us about exciting higher energy events. And in each of these, M82 in particular looks completely different.
Yeah, I mean, if we look at some of these images from say Spitzer or Herschel, these infrared images, M82 looks very bizarre indeed. We see these plumes of gas and dust that are coming out of in this image, the top and bottom of the galaxy, whereas the stars that we see with optical light are along the line of the galaxy, which is pretty much left to right.
Yeah.
And that's in contrast to M81. When we look at M81, the dust we see in the infrared with Herschel, for example, traces very well the spiral arms we see in optical light, and that's because the dust is where the stars are forming. The dust is occurring in the same place.
But in M82, it's out above and below the cigar, much further than the length of the cigar. This is a huge outflow of gas and dust, and it's moving very quickly. So the question is, what on earth's caused it?
Well, we know now that most big galaxies, or possibly all, have black holes inside them. What about M82, which is a big irregular?
We think that it almost certainly has a black hole in its centre, and we can establish that just by looking at the speed at which the gas and the stars are moving. So we can tell there's a black hole there, and that could be one of the reasons in some galaxies you see these very energetic outflows of gas coming out of the poles of the galaxies, the top and bottom of the galaxy. But we don't think that's the case here.
Are there any indications of interactions between these two galaxies, as was once thought?
Well, that's a solution that people have often gone for, because one way you could get this dramatic outflow is if you have lots of star formation, and we know we've got lots of star formation, then the stars themselves have winds which can contribute, and in particular young massive stars go supernova, explode, and those, if you have enough supernova explosions, you might expel a lot of gas. So then the question is, how do you get lots of star formation to produce lots of supernovae? And one way to do that is to have collisions or interactions between two galaxies. When two galaxies collide, the stars don't. There's enough space between the stars that the two galaxies can pass through without stellar collisions happening. But the gas and the dust does collide, and those collisions trigger all sorts of star formation. And so one possibility is that M81 and M82 used to be interacting. So if we think that's an explanation, we need to test it. And people thought they had the smoking gun.
There are these streams of dust that come out of the top of M81. This was something called ARP's loop. These streams of dust, there were also streams of gas. And it was thought that these had been pulled out of both M81 and M82 as the two galaxies had passed. And
just as we see with galaxies like the mice or the antennae, which we know are interacting.
And certainly M82 looks to be very disturbed in its shape as well. It's thought that possibly it's a galaxy that's lost its disk. The disk has been stripped off by this interaction between the two galaxies, leaving just the central bulge, which is one reason it could look so bizarre. But new research has shown that the gas and dust we see there appears to be moving at the wrong speed to be associated with these galaxies, and it's actually gas and dust in our own galaxy, the Milky Way. It's much, much closer than these two galaxies are.
How far away are these galaxies from us?
Well, they're still pretty close, something like 150,000 light years, which is really close for two galaxies. I mean, one of the reasons that we know so much about M81 and M82 is it's one of the nearest little groups of galaxies, and it's not far off a clone for our own local group, of course. If we know the Milky Way and Andromeda will collide in a few billion years' time. I suspect in maybe 6 or 7 billion years' time, we may look very much like M81 and M82 do. How we'll end up depends on the exact details of the collision. So I can't say for sure, but it's certainly a possibility.
Well, they make up a remarkable pair, and if you've got an optical telescope, do go and have a look at them. They are very well worth seeing. But of course, they are not the only galaxies in Ursa Major. Outside of my garden, Pete and Paul are having a look at some of the other island universes in the Great Bear.
Well, at the other end of the plough, there is another interesting galaxy.
Yes, there is. One of my favourites, actually. M101, the Pinwheel Galaxy.
There's a lot of galaxies in the sky called Pinwheel, aren't there?
There are. I think this one genuinely does, though. In the pictures I've seen of it, it looks quite fantastic.
It does. This is another spiral galaxy.
It is indeed.
Which we see exactly face on. So we're looking right down the top, or perhaps it's the bottom of the galaxy, you can tell. But it's quite an easy galaxy to find.
It is. It's actually quite a big galaxy. Our own galaxy is about 100,000 light years across. This is 170,000 light years across, almost twice the size of our own Milky Way. So it's quite an impressive galaxy.
It is. And when you sort of work out how large that galaxy is going to appear in the night sky, given those figures, it's about the same size as the full moon again. So it's quite a large galaxy. But its brightness is spread out over quite a large area, so its surface brightness
quite
becomes quite low,
yeah.
and that makes it difficult to see.
But it is rather easy to find, though, isn't it?
It is. You can use the end star of the handle of the plough, Alkaid, and the next one in, which is Mizar. And if you imagine those two stars as one side of an equilateral triangle, then M101 makes the other corner, if you like, of the triangle, just above them.
So easy to locate. But of course, M101, not the only one. What about M108? This is a very difficult object, isn't it?
It's one of the harder objects in Messier's catalogue, which is very close to another Messier object, M97, the Owl Nebula.
That's right. And this is quite an interesting galaxy, isn't it?
It is. It's an edge-on galaxy this time, so we just see it again a bit like M82. It looks just like a linear patch of light in the night sky.
I struggle to see it with a small telescope, if I'm honest. I find it quite difficult.
Well, it hasn't really got a sort of central condensation in it. It just looks sort of fairly even in brightness, and through a large telescope it does look quite mottled in the centre.
Yeah, and also we have M109, and I gather this is a rather late addition to Messier's catalogue, added in 1953.
It was.
And this is a barred spiral galaxy, isn't it? Which is also a very pretty galaxy to look at.
That's right. So it's a galaxy with the central bright core, but that's elongated out into this bar, and we see it tilted over again, and that gives it a rather peculiar appearance through a small telescope.
It does. It looks rather pear-shaped, I found.
That's a good description of it, actually.
It's a small telescope. Very nice.
But that's, again, quite easy to locate because it's very close to the star Fad, which is in the bowl of the plough.
Yes.
And it's about 40 arc minutes. That's just over a moon diameter to the southeast of that star.
So all these galaxies, well worth taking a look, I think.
Absolutely. And speaking of galaxies in Ursa Major, it was the Hubble Space Telescope that made an amazing discovery in this region.
What would you do if NASA gave you the controls of the Hubble Space Telescope? Not just for one night, but for 10 solid days. Well, when this happened to a group of astronomers more than 15 years ago, they decided to look at the most boring patch of sky they could find, just above the star Megrez in Ursa Major. It's an apparently empty patch of sky, but Hubble transformed it into a beautiful picture of distant galaxies called the Hubble Deep Field. Every single object in this image, with a couple of exceptions, isn't a star, but is a galaxy containing hundreds or thousands of billions of stars. Some of them are relatively close, only a few billion light years away, but some of them are more than 10 billion light years away. And that means we're seeing the universe in its infancy, at a time when galaxies and stars were just forming. The amazing thing is that when you look at these very distant galaxies, they're smaller than the galaxies we see around them today. They have younger, different populations of stars. We're seeing the building blocks of what became the universe that we see around us. It's a remarkable confirmation of the Big Bang Theory, and it's a remarkable image.
Well, for this programme, we looked out into the far reaches of the universe and seen galaxies in one of our favourite constellations, the Great Bear. Meanwhile, don't forget to look at our website, bbc.co.uk/Sky at Night. Also, in the opening evening sky, there is Jupiter, now a brilliant, splendid object, and strange things have been happening there, and it now seems that the missing south equatorial belt is on the verge of coming back. We've just got to wait and see what happens. When I come back next month, we're coming much nearer home and talking about volcanoes in the solar system. So until then, good night.
Our brand new series, The Beauty of Diagrams, unravels the simple elegance of Florence Nightingale's Rose diagram. That's here on BBC4 on Thursday at 8:30. And coming up this evening at 9, a brand new programme uncovers the joy of stats with Professor Hans Rosling. Next, though, we meet Philip Larkin's Third Woman in a tribute to the much-loved poet.